Hello everyone, welcome to this series on solving distributed system challenge. So the challenge of today is implement a Chord DHT on Golang. So imagine your distributed system facing network failure and split brain scenarios and conflicting updates. So can each survive? So today we are tackling one of the Jawa's challenge by building a Chord Distributed Hash Table, short for DHT, using Golang that can handle network partition while maintain a strong consistency. So first, let's define what is a distributed hash table. DHT is decentralized data structure that store and retrieve key value pairs across multiple nodes. It is essential for scalability, for tolerance, and efficient lookup in distributed system. We already know DHT are widely used in a peer-to-peer network, blockchain, and file systems like IPFS or stands for IPFS, and they solve the problem of centralized data management by providing an efficient, scalable, and resilient way to manage data in the centralized network. So the challenge we implemented is simplified and powerful. Um, we will use in Golang, and we will use some key distributed system technique like finger tables. That finger tables is implement finger tables for structure routing system that allow efficient lookup in all login time instead of searching every node. And the vector clock, this is very important pattern in distributed system. This method is to track and resolve conflicting updates when a node reconnects after a partition, and the self-healing partition, and interactive CLI. And we will build in a command line tool to insert data, simulate network failure, and watch the system recover in real time. So by the end, you'll know how to handle distributed system failure like a pro. So before we dive into the code, let me show you what we're building. So this is a simplified uh, distributed hash table. It allows to store and retrieve a key value pair efficiently across multiple nodes. So first let's type help. Cool. This is all available comments. So let's take a look of how it works and define what is comments for. So start comment is initialize the DHT which a specified number of nodes, and put store a key value pair. This is then determine which node is responsible for storing the data, and get is retrieve the value associated with the given key from the DHT. If the key doesn't exist, it returns an error. And partition simulates a network and partition by dividing nodes into separate groups that cannot communicate with each other. And heal is the result of network partition. And status display the current state of DHT, including active nodes, partition, and the stored data. And at least help and exit. Uh, Help is list for all available comments, and exit terminate the program. So, for example, if we started this sheet with a for nodes, let's type comment start for. Cool. It's start DHT with a for node. So this means each node is assigned an ID and is ready to store and retrieve the data. Okay, the next comment is put, and put. Let's give an example. Put Golang Rust. Okay, cool. So what happened in here? The DHT assigned Golang to specific node based on its constant hashing mechanisms, and the value of Rust is storage under the key of Golang. And the next command, let's do get retrieve a value like get Golang. Cool, it return Rust. So the system successfully found the Golang in the correction node and return the value Rust. And create a network of partition by typing partition command, and partition, let's do 1 2. Okay, the node 1 and 2 are isolated for the rest of the network. This simulates a network failure, mean nodes in a different partition cannot communicate. So we will be hailing the network. Cool. The system detects that node were a partition, so the network is restored and nodes can now synchronize data. And finally, we still have three common status, help and exit. Status, this type of status to see better what's happening. Cool. The status is display the current state, showing active nodes and their stored data. And okay, everything working fine. Let's now dive into the code and then explain each function, each types. Okay, let's do exit. And exit for terminate the program. Fine. Okay, friends, we are now in the coding section. So in this section, we'll define the core type for Chord DHT implementation. First, we have a Victor clock, which will store inversion and timestamp for data conflict resolution. And next, we have data item, which we're representing the actual data being stored in the DHT. And then we define the node type, which representing a node in the core ring, and finally the Chord DHT, which tie everything together for our distributed hash table system. And okay, we say okay. What's we have? First, let's define the data item. Vector clock is a map of int that return int, and data item is value is a string, and okay, and Victor clock is Victor clock. Cool. And the node that we say h before for representing node in the core DHT, and we have ID, and we have data, and partition ID, no, partition ID, yeah, and the mu for mutex, and Victor clock is Victor clock, and mu is assigned dot mutex. This is for trade safety, for trade safe, and partition ID is integer, and data is map of string return data item, and ID is integer. The ID represents the node ID, and the Chord DHT. The Chord DHT contain nodes. Nodes is slice of pointer of node, and contain partition, and the partition is map of int, which is slice of int, and another mu sign dot mu text. Okay, fine. We will represent the comment later, and let's define a first function is new core DHT. It creates a new core DHT with the specified number of nodes. We'll complete it later. Find new core DHT. Return num of lots is int, and return no. DHT is nodes is make and make slides of nodes and the partition, and the partition is make map of integer slides of int. Nice. And now we will initialize the node init. The node init nodes. Okay, we have node IDs is make slice of int and no floats. Nice. And for I do a for loop statement. No nodes. Node IDs of index I return and DHT dot nodes of index I is equal. Nice. We have an ID is I and data is make map. Nice. And the partition ID 0 and vector clock is make a vector clock. And what we have, so let's do DHT dot partition this for all nodes start in partition 0. Okay, is equal nodes ID. Nice. Return DHT. Fine. And the first function we will implement is put. We represent a put. What is it? So is store a key value pair in the DHT. Put stores a key. Key value pair in the DHT. So we have a find. We've got DHT put. We have a key and the value, and is a string and node short for node index is int return and error. So check if the node index, let's check for node index is valid. Chord DHT dot mu dot error. What? Wait. Nodes for nodes index and partition. No. Is no dot partition ID. DHT dot mu dot run lock. I think we have a problem here. DHT dot mu dot What's happening? Ah, I define mu as a mutex. What the fuck? I think now we're working fine. Cool. And the partition ID, that I not use it yet. Fine. We will do a sample routing. Target node is node for underscore n to ignore range of DHT dot nodes. Which let's do if statement if n dot partition ID is equal partition ID. Clearly fine. And target node equal n do break statement. Fine. And update the vector. No. Update the vector. Update the vector is target. Target node dot mu dot lock and new clock. I think I forget some operator function using vector clock is clone and increment and merge. I will do this later. Clone and increment and merge. What is meant by this function? Clone is return a copy of the vector clock, and increment is increase the clock for the given node ID, and merge. Merge is acts or I mean combine two vector clock for taking the max of each position. Okay, we have find little VC of vector clock is clone. Fine. And the vector clock and clone equal make of vector clock and for key and v is equal range of VC. I mean VC first. And then clone of index key is equal V. Fine. Return clone. A quick comment. Clone is returns what we say before. A copy of the vector clock. And next function is increment. And the next function is increment. I'm just got a new laptop. I feel like increment is increase. Yeah, increment increasing the clock for the given ID. So we'll do find of increment and we declare a node ID is integer, return VC of node ID. Oh. Okay, the next function is merge. Okay, merge is comparing to vector clock and checking the max of each position. And we have func merge. Let me declare merge a variable called order, and the order return vector clock, and this return a vector clock. Fine, and we have no. Let's do result equal vc dot clone. Nice, and for key, and this equal range of order if current and exist. Yeah, is equal result of index. We'll do a for loop statement not equal exist, or v is greater than current, return result of index key equal v. Fine, return result. And as we say, increment is increase the clock for the given node ID, and merge is combines two vector clock. I have a problem with upper cases. Taking the max of each position. I will update the comment later in the last of this video. And this item, we say it represents and a stored value, which is a vector. Node is a node in the Chord DHT, and we define the put variable. We know don't complete the put function. Okay, what do we say? Target.mu.lock. We'll do sample routing, and the sample routing. So we say update the vector clock. We have target node dot mu dot log. Fine, and new clock is equal target node of vector clock dot clone, and we have new clock new clock dot increment target node ID, with let's update or insert the data. We have data item is equal data item of value return a value, and vector clock return new. I say new clock Okay, and now let's check for conflicts with existing data or stable data item. Okay, let's do first checking for conflicts with existing data if existing item equal target node dot data. Oh, why am I target node declared? Okay. We have Victor clocks. I think I will stop the recording. I will go to sleep and we continue tomorrow. And I think I will pause the record and give the ALDI code for not wasting much time because the record is still longer and this is much implemented function. Okay, continue tomorrow. Okay, finally I'll stop it in this statement and we'll declare a target node of data index k return data items. This stands for store the data item, and this for statement is for replicate the other nodes in the same partition. Let's type in it. Replicate two other nodes in the same partition and return nil. And we have a function of get, and we are presenting what is mean by get in the first of video is for retrieve value for k from the DHT. Let's type in it. Retrieve a value for key from ice. Get is key string and another index is integer, and declare a concurrency model which x and a for statement. And for this implementation is try to get the value from this node, and this for statement try other nodes in the same partition. And we have another function is create a partition. Create a partition for divides the network into a partition, and the DHT partition is for clear existing partition, and the for statement is for create a new partition, and this is for create a new partition, and this for update nodes with a new partition ID, and this store partition information. I will do all this explanation in the last of video, and I will push the project on GitHub, and you will see all this on detail. And what we have also another function is called a hello partition, and the hello partition for reunify the network. So all data variable for collect all keys and their value from all partition, and this for a statement to iterate through all nodes and collect data, and resolve data means that conflicts resolve under conflicts and create a unified view. And this is for resolve an ID equal item index 0. This is for start with the first item, and the for statement is merge two merge with other items, and this is for merge merge a vector clock, and if len item index of dot value. This is use the value from the latest update. In the real system, you need a better conflict resolution strategy. And what we have also variable node, another variable called node IDs. This for unified a node set to partition 0 and update data. And this part for research a partition ID, and this for update which resolve the data, and this for statement for merge all vector clock, and this for unlock the node and research partition. And we have another branch status for display the current status on the DHT, and we have a branch DHT status, and we saw this example on the first of the beginning of the video and how it works. And this is for branch partition, and this is for branch node data. Okay, and finally main function. This is DHT for initialize the DHT, and we'll do a command loop. Command loop for the command that we're using in the first videos. This if len x is equal 0, this one handle empty input, and we use a switch statement for commands. This is start for representing a start command. This for check the argument is valid, and the case put for the put commands, and the get for get command, and the partition for a partition command. And okay, for here status and help, and I had to show all the common definitions and description, and the final comment is exit and quiet, and everything working fine. So I have to find its valuable. I love distributed hash table so much. So, and then I ask myself why for not to make a video to explain it, and I have to explain it in a better way. And let's check if they work fine. Go. Okay. Okay, everything working fine. So you come back to the first video to see this available comment how they work for not to waste much time. So thank you so much for your time, and see you in the next video.